Hello everyone. Let's start solving this problem from motion in a straight line. ये सवाल आपको मेंस 2018 में पूछा गया है. This problem says that all the graphs are intended to represent the same motion. One of them does it incorrectly. As I have said earlier also, just focus on the wordings of the problem. जेई के प्राइमरली क्वेश्चंस की डिफिकल्टी एस्केलेट इसलिए भी होती है कि मेनी अ टाइम डिफिकल्टीज आर हिडन इन द वर्डिंग्स. इफ यू स्टार्ट अंडरस्टैंडिंग देम प्रॉपरली आप काफी इजीली सवाल को सॉल्व कर पाइएगा. यू विल स्टार्ट सीइंग सर्टेन पैटर्न्स इन द प्रॉब्लम जो आपको बहुत हेल्प करेगा गोइंग फॉरवर्ड इन सॉल्विंग देम. सो व्हाट आर दोस कीवर्ड्स हियर इन द प्रॉब्लम. यहाँ पे कीवर्ड क्या है? कीवर्ड ये है कि ये जितने भी ग्राफ आपको दिख रहे हैं ए बी सी डी, दे आर सेइंग कि it has to represent the same motion but one of them is representing it incorrectly और आपको वो find करके बताना है. ऐसे सवाल में कैसे begin करें? What shall be your approach? So the general principle says is you start with the graph that you are most familiar with. और इनमें से आप कौन से ऐसे ग्राफ हैं जिससे आप सबसे ज्यादा familiar हैं? It is position time, right? So let's start looking at the position time graph here. So you can see at t is equal to 0, the particle is at origin, and at t is equal to t, it again returns to origin. There is about one special property about this graph, which is it gives us point velocity. It gives us point velocity. That is, velocity at time t is given by dxt upon dt. किसी भी पॉइंट पे अगर आप उसका टेंजेंट ड्रॉ कर रहे हैं तो वो उस पॉइंट का इंस्टेंटेनियस वेलोसिटी बताता है. एंड दिस इज द ब्यूटी अबाउट द पोजीशन टाइम ग्राफ. हम चलते हैं तीन टेंजेंट ड्रॉ करते हैं यहाँ पे. से एट t is equal to 0 we are drawing one tangent. At some point t is equal to tau or t is equal to t prime we are drawing one tangent which is parallel to your time axis. And then at t is equal to t we are drawing one another tangent. Let's look at the thetas around it. This is theta 1, this is theta 2, and if you look at the tangent at t is equal to t prime, it is making 0 degree with the time axis. So let's now enumerate the instantaneous velocity at these three time instances. तो कैसे दिखेंगे ये? तो velocity at t is equal to 0 equals tan theta 1 which is greater than 0. आपके पास डी ऑप्शन में velocity time graph दिया हुआ है. At least you can infer from here that t is equal to 0, it starts with a positive velocity. That means there is some consistency between option C and D. But let's go and see at t is equal to t prime. Velocity at t is equal to t prime is equal to tan 0, since it is making 0 degree with the time axis, which is nothing but 0. So velocity वहां पे 0 हो रही है. आपको ग्राफ D में दिख रहा है कि it cuts the time axis and velocity becomes 0 at t equals to t prime. Correct? Now, let's look at velocity at t is equal to t, which is tan theta 2, correct? And since tan theta 2 is negative, it is an obtuse angle, so it's negative in the second quadrant. And you can see in graph D that velocity becomes negative at this point in time t. So C and D appears in perfect sync. Now what you can see, that instantaneous velocity somewhere between t is equal to 0 and t is equal to t is becoming 0. That means somewhere between t is equal to 0 and t is equal to t, your speed will also become 0. Now you quickly look at option B here, which is distance time graph. And if you take a derivative dxt by dt, it gives you an instantaneous speed. But can you see any point between t equals 0 and t is equal to t where your velocity is becoming velocity is become your speed is becoming zero? Absolutely not. You are not getting any t prime such that your tangent is becoming parallel. Rather, you are getting your tangent parallel to time axis at t is equal to t, which is not the case you are getting from these two graphs. It, the, the instantaneous velocity is becoming zero somewhere between t is equal to 0 and t is equal to t, that we have inferred from graph C and D, not at t is equal to t. This gives you, this clearly eliminates, this clearly gives you the right answer as B. Means you can quickly, since it says that one of them is incorrect, so you are pretty much sure that B has to be incorrect since C or D are consistent. But what about A? अगर आप जानना चाहें कि हम A को कैसे infer करें, तो now look at the wording of the problem. It says that all the graphs are intended to represent the same motion. Now, if C and D represent the same motion, then what we have? Think about it. If the motion is what has been given in graph D, then your velocity time graphs is a straight line, correct? And derivative of d, we know that dvt by dt is equal to acceleration. This implies acceleration a is some constant negative k from graph D. We also know that acceleration can be written as v dv by dx, which is here negative k. This implies your v dv equals negative k dx. Why we are doing so? We want to get velocity as function of position so that we can get a velocity position graph, correct? So if you integrate both sides, you get v dv equals negative k dx. Your k is constant. This implies v square by 2 is equal to minus kx plus c. It's a parabola, which is rightly represented in option A. So what do you understand over here? You understood that option A, C, and D are consistent and they represent the same motion. However, B is not aligned with the motion that A, C, and D represents. Then that's why it has to be incorrect. So this is how you deal with such problems. We will look at many more in the coming videos. Thank you for your time.